Hello, everyone. Thank you for joining us. Today's session is the second in a three-part series on artificial intelligence, where we will discuss various concepts to help you learn and implement AI in your applications. In today's session, we will cover the computer vision services available on Microsoft Azure, and you will learn how to create a simple vision model using sample images. You will also be able to train, test, and deploy the model and learn how to integrate it into your own applications through APIs. My name is Hassan Mohsina. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there's something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. We continue the series with Dalia Tarek. Dalia is an Azure technical trainer at Microsoft specialized in data and artificial intelligence. Passionate about AI, machine learning, and data analysis, she keeps the customers up for success by providing deep technical consulting and advising through her trainings. Keep the Q&A tab open as I will be sharing some resources. I just dropped the link for the first part in the series. If you have missed it, you can go on our YouTube channel and catch it. And also you can send us all your questions during today's sessions using that Q&A tab. The session is recorded and it will be available on our YouTube channel. And I highly encourage you not to miss the third part as well, happening next week. So without any further delay, I would like to hand over the mic to Dalia to start today's presentation.
Thank you so much, Hussein, for an amazing introduction. All right, I'll share my screen now and I'll get it started. Okay, thanks everyone for joining today's session with Microsoft Reactor, and this is the second session for Vision Services. As Hassan mentioned, I'll reintroduce myself as well. My name is Dalia Tarek, and I'm a technical trainer for data and artificial intelligence based in UAE for Microsoft. So for today's session, in the first session, if you attended it, I explained cognitive services on Azure, which are the ready-made API services available for artificial intelligence that are ready-made for you to use inside of your application. So they're already built on the cloud. They're made in a way of APIs that you can integrate it inside of your application without having to develop or code or do any hard work on your side. You just integrate it in your application with an HTTP request and get the results as it is. So for this session, for the next one, I'm going to go into a more hands-on option, and I'm going to go through some labs and show you how you can do this just from scratch, how you can start integrating cognitive services, computer vision onto your application. And of course, the most interesting part of this is the vision services, in my opinion, because usually working with images, you can see the result right away, and you can get the best results when you just work with them with your hands. So as I mentioned earlier, I was talking about cognitive services, and these are all of the cognitive services available on Azure. They're APIs. They're built on the cloud, and you just use them where you send a request with the document or the data that you want to analyze, and it gives you the result in the form of JSON. So for today, I'm going to talk about computer vision. So for computer vision, we have all of these services available that lie under computer vision. So computer vision is basically the part that has to do with images or videos. So basically, you're teaching the computer to see as a human. You're teaching the computer to understand what's inside of an image or a video, just like a human does. So we have different options. We have computer vision, which is the basic API, and it basically analyzes generic stuff inside of an image. So if you give it an image of the sea, it's going to understand that this is a sea. If it's an image of a building of a car. So some generic stuff that's already built on Azure, that's already trained, then you can find it under computer vision. Now, if you have some stuff that might not be available on computer vision, that might be more customized to your own needs, might be different, or might be something very specialized that you need to train it on inside of your company, then in this case, you can use custom vision. And custom vision basically allows you to train the API with the images that you want and everything inside of the images that you want to detect. And it gives you the result in the end once you train the API on your own. So you just customize it to detect what you want from the images, and it's very customized to your own needs. The third option is Face API. And Face API basically just is purely for faces. So it detects faces inside of an image. It detects whose face it is. So once you train it on a specific face to identify it, later on when you give it an image of this face, it's going to learn that this face is Hossein, for example. Then it's going to detect later on that where Hossein is inside of an image. It can even detect emotions if someone is happy, sad, angry. So there is an emotion detection option available as well. And there's also form recognizer, which is specified for, let's say, if you have any invoices, any PDFs, any scanned invoices, for example, or scanned receipts, then it's trained to detect what's inside of this invoice and then give you the result in a tabular format, just like the invoice is. And I'm going to show you some examples as well on this. And there's also ink recognizer and spatial analysis. So ink recognizer is available for handwritten text, for example, or if you have any scanned documents or scanned images, handwritten text, then you can find it under the vision services as well. And spatial analysis is basically for any video or any live video as well, or live streaming, and it basically analyzes what's inside of the video and gives you the result in the end. Now, the way these services work is basically you give it the image and it gives you the result like this. So over here, this is for a face API. So I basically sent it the image for a person inside of the image, and I sent it to the face API that I created, and it gave me the result like this. First off, it gave me a bounding box of where the face is. So it detected the face inside of the image and gave me the location of the face. And then it gave me some information like gender, age, glasses, and emotion. This is just an example of what you can get from computer vision or cognitive services in general. It gives you the results like this, some analysis about the image itself without having you to write any code. Okay. Now let's have a look at what is computer vision services, cognitive services on Azure, and how you can deploy it and how you can use it. So over here, this is a demo website available for your use. And the way you basically use it is just you send an image and it gives you the result like you want. So it's just a demo page. Over here, this website is using the cognitive services API in the backend. So basically, let's try out and analyze one image. So if I try this image, for example, this is an image of a scenery of a skyline. And these are the results that I get under computer vision. So over here, you can see this image. It has water. So it identified the water, sky, lake, outdoor, some skyscrapers, overlooking reflection. So this is automatically detected from the computer vision API on its own, without having to train it, without having to specify anything. It's automatically trained to look at all of this. And also it gave you a description. So give you that this is a bridge over a body of water with 80% confidence. Now, with everything that it analyzed, it gave you a number, a percentage, and this is basically how sure it is of what it just identified. So it's 100% confident that there's water, but it's 33% confident that it's overlooking something. Or there's a reflection, 61% confidence that there's a reflection. So this allows you to just, whenever you're choosing the tags that are extracted from the image, it allows you to choose the most accurate tags and then drop out the tags that are might not be very accurate, because it might just ruin the accuracy of your entire system. Now let's try out another option. Let's try and read text inside of images. So let's try this images over here. So this image is just an image and it has a sign inside of it, and the sign has some text. So the way it works is it uses optical character recognition technology inside of computer vision, and it just detects the text inside of an image and turns it into digital text. So this image, for example, over here, it was detected the number 42 street and this number as well. And the way it was working as well, it was just we sent this image to the API and the result came out like this. Now let's try out some handwritten text. So this image over here, it's handwritten like this. So we just sent it to the API, and using OCR as well, or optical character recognition, and this one is specified for handwritten. So it was able to detect the handwriting and then turn it into letters and sentences, and in the end, digital text extracted like this. So this might be very helpful if you have any old documents, if you have any scanned documents that you want to just analyze and have it applicable for search as well. So you can use this as well inside of your system. Another option is recognizing celebrities or landmarks. So let's have a look at this image, for example, of the Statue of Liberty. So I just sent it the image as well, and it detected that this is a landmark and gave us the confidence for this landmark. So this was how you apply this in real life. You just give it the image and you see the result like this. Now let's go into more hands-on and see how can we create something from scratch, and then how can we analyze our own images. So this is all on Azure, on Microsoft Cloud, and the way it works is basically you connect using your account on your own subscription, and then you create a resource called Cognitive Services, and Cognitive Services basically contains everything that you need for API machine learning. So let's create a resource over here. If I click on Cognitive Services in the search, I just click on the resource, click on a new Cognitive Services resource, and it contains all of the services that I mentioned earlier. It's available under Cognitive Services. So over here, I click on Computer Vision. And this is how I'm creating my resource. I'm just choosing a resource group. Resource group is basically a folder where you just combine all of your resources in together just to organize your resources. And then I'm going to choose a region. So Microsoft Azure is available on different regions all over the world. So you can choose whichever region that is closest to you or that you're comfortable with. So I can choose whichever region I want. There is also a region in UAE North, so I can choose that as well. It's available in UAE. And then I'll give it a name. It has to be a unique name. And then I choose the pricing tier. So we have two tiers over here. It's either free, which has a limited amount of calls per minute. So it's calculated. So for each request that you do to the Cognitive Services, this is one call and it's calculated per call. So it depends on how many calls you do to the cognitive services. This is going to be your pricing option. So it's either free, which allows you 20 calls per minute only, or standard, which allows 10 calls per second. So you choose whichever you want. Of course, standard is the one for production. Free can be for trial. If you have an account and you want to try cognitive services, then you can choose the free option. And then I create my resource like this. Now it's deploying. And this is my created resource. So this resource over here allows you to connect to the resource through this endpoint. So what you get basically is just this URL and a key. And the way you work with it is just you send a request to this URL with the key and you get the answers in JSON. Okay, and over here you can gather your keys, and these are for security purposes for you only to use. All right, so now let's go to and see a live example. So over here, this portal is available for you to create the API requests with. It just makes your life easier. Instead of using the command line or something, you can just use this portal over here. It's basically the documentation available for all of the cognitive services and specifically for the computer vision API. And through here, I'm just going to try out some requests and get the answers like this. And the way it works is basically you give it the URL for cognitive services, add in your key, and then add in any parameters or headers. This is a typical HTTP request, post request. And you add in the subscription key over here. And in the body, you give it the image that you want to analyze, like this. And then you get the results like this. So let's try out with the cognitive services that we have. So let's go to our keys and endpoints. So over here, this is my endpoint. And let's take in my key. We'll just go to the API specific to North Europe, since I deployed mine in North Europe. Okay, so I basically just add in my key, and I have my endpoint ready for my cognitive services resource. And these are just some parameters available. So you add in the language and the categories. So these are all of the things that you want to detect from the API. And under URL over here, I'm just going to add in a test image. So let's try out this image, for example, for a dog. And add it over here in the body. I just copied and pasted the image, URL, and then I'm going to send the HTTP request. So this is the body of my HTTP request. It's a post request with this URL. This is the key, and this is the URL available that I sent for the image. And this is the result that I get. So you see here for this specific image, it's an image for this dog, and I wasn't able to detect it very well. So it just detected as others because the request wasn't very available. So now let's try out another image for this one, for example, for waterfall, and let's see what it gives us the result for. So for the dog, it was able to detect that this object is a dog. So I just chose object detection option over here. So you have, these are all of the options. I'm just choosing the object detection. So it was able to detect that there's a dog in the image, and it gave us the location of the dog inside of the image, XY position, and over here just some details about the image as well. Now let's try out another image. This. So I just sent it the image for the waterfall, and it was able to detect it like this with not a very good accuracy. So because the API is not very well trained to detect waterfalls, then it gave a confidence of 0.5%. Now, what can we do in order to detect something very specific to me, for example? So if I have something that I want to detect and it's not available on the API. In this case, we have something called custom vision. And custom vision basically allows you to deploy your own API by training it with your own images. Now let's see how can we do this. Over here, I have a portal called Custom Vision. This is a portal that allows you to train your own API, connecting to Microsoft API as well. So I'm just going to sign in with the same account that I have. And after signing in, I have my projects like this. So through here, you can create a project that detects a specific type of image inside of the project and then get the results later on. Now, let me show you an example. So over here, I have just some code for computer vision, connecting computer vision API. This is some C# code. And what I want to do is basically I want to give it my image that I want. So let's try and take out an image of this painting, for example. So I have this painting. And I've already trained my vision model to detect what's inside, who is the, if this is a painting or not, and who is the painter of the painting. So what I want to do is basically I want to upload this image and then send it to the custom vision API customized for my own painting that I just trained it, and then get the result in JSON. So now I just want to get this painting over here. I'll add in the path and like this. So I'm just sending this image to my custom vision model. And this is the result that I got. So let's have a look at what's inside of the result. Over here, there are some predictions with a probability over here of 0.999% that this is a painting. So over here, it detected that this is a painting with a 99%, it's 99% sure that this is a painting because I trained it to detect paintings. Now the next detection is 0.993, sure that this is a Picasso painting. So you see over here, it was sure that what I gave it is a Picasso painting, and because I trained it to detect what's a Picasso painting and what's a Van Gogh painting and what's a Rembrandt painting. So I trained it to detect all sorts of paintings and all sorts of painters and detect whose painting it is. And for the rest of the painters, it just detected a very, very poor probability. And that's what I want. I want to send it any image that I trained it to detect, and it gives me the answer as accurately as possible. All right, so how can we do this? How can we train something like this? Let's see. Now I'm gonna create a new project over here, and I'm gonna name it painting demo. And over here, you can see it's connected to Azure, to my Azure account, and it detected the resource that I created earlier. This is my resource, so I can just connect to it. Now, for my project types, I either have the option of classification or detection. So detection meaning that if I give it an image, it's going to detect if there's an object inside of an image or not. So if I give it an image of a car, it's going to detect the location of the car inside of the image. With classification, I just give it two categories or more, and it's going to classify the images into category A or category B. So in my case, it's going to identify the paintings into painter A or painter B. It was painted by this painter or that painter. So this is a classification project. I'm going to choose multi-label, meaning that I'm going to have different categories for each image, not just two categories. And you can choose different domains to help you out with the training. So if it's something food related or landmark related, then you can choose it. But in my case, this is something very generic because it's about paintings, so it's probably not there before. So I'm just going to choose a general domain. And now I'm going to create my project. Okay, so now I have a new project to train my images. This portal over here is just a tool for you to train your cognitive services API that we created on Azure over here. So it's connected to the same API over here. Now let's try and add in our images. Let's try out and connect over here to my folders. So under my folders over here for training, I have the first folder for the artists, which has these three artists, Picasso, Pollock, and Rembrandt. And the first folder contains the paintings of the artist. And the second one has his paintings as well. And the third one. So this is going to be my training data. This is how I'm going to train my API with some sample images, and I'm going to label them, and I'm going to just guide my API that this painting is for Picasso, this painting is for Pollock, and this painting is for Rembrandt. Okay? So let's see how can we do this. First off, I'm going to upload the paintings for Picasso. So I'm just going to choose these paintings over here. Now, while uploading the paintings, I'm just going to give it the details or the categories of this painting. So first off, I want the API to classify if this is a painting or not. So I'm just going to type in painting. This is my first tag, painting. Now the next tag is I want to label this as a Picasso painting. So, hey, API, learn that this is what Picasso does. This is his paintings. Okay, you need to learn this because in the future, you need to detect a Picasso painting. And how it basically works is that it detects all of the common features between all of these paintings, like the coloring, the pixels, some features with the lines. So it detects all of the common features between these. And later on, when you give it a whole new image that it hasn't seen before of a Picasso painting, it's going to understand that this has some similar feature to the Picasso paintings that was available, and then it's going to detect that this is a Picasso painting. That's basically how computer vision works. Detecting features, understanding the features, analyzing what's in common between these images, and then looking for these features in the new image and detecting what it is. So now I've uploaded the images for Picasso over here. Let's upload the rest of the images. Okay. This is the second artist. So I'm going also to train it to detect the painting. And this is for the next painter, which is Pollock. So I'll upload these paintings as well. And I'll add the other images, which are Rembrandt. I'll upload it as well. Also tag this as painting and tag the name of the artist. Okay, so now I have all of my data sources available. This is the training images that the API is going to use to learn what it is going to detect. Okay, so after uploading the images for the paintings, I'm just going to click on train. And the training basically connects to the API on Azure, gives it the images, and then does all of the algorithms, goes through all of the algorithms for training the images and understanding the images, and then coming up with the best accurate algorithm possible, or the best accurate model in terms of machine learning, the best model that it could in order to detect the images. So right now it's training, it's going to take a bit of time.
Dalia, a quick one here. Your audio is gone.
Yes, I'm just waiting for the training to, for computer vision to do the training. And once it's done, we're going to try it out. And if you have a look at just our cognitive services resource over here, you can just have a look at some details or some metrics. So these are just some details that you want if you want to monitor your resource, how it's being used, how many requests is it getting. You can try it through here as well. So let's try out something. So you see here, this is a chart available for the data coming in for the Cognitive Service API. And you see it's peaked over here right now because right now it's doing the training. Let's try out another one. For the calls, so over here, this is the amount of calls that's happening for the resource as well. And you can see right now it's peaked because it's getting a lot of calls from my custom vision training. It's still training, so it's now currently it's taking all of these images, analyzing the pixel, analyzing the coloring, analyzing everything, and getting the results. And you also have the option to have a look at the logs for the resource itself and see what were the results from the connections, what were the results from the training and testing, all of this. Okay, so now after 3 minutes, approximately, we're able to train the model like this. So over here we have information about the accuracy of your model, precision, recall, and a measure of performance over here. And this is the performance for each tag. So each tag that we identified it with, it was able to get this accuracy. So it's all very good, 100% precision. And these are the amount of images that it was able to detect. So 19 images of painting, 7 images for Picasso, 6 images for Pollock, and 6 images for Rembrandt. Okay? It was trained through these images, and now it's trained to detect which painter it is whenever it gets a whole new images. So over here under my folders, I have a folder called Quick Tests. So other than the images that I trained my model with, so I trained my model with these 7 images. Now I want to make sure that the model is really, really smart, that it's very, very accurate and it's working as it is. So I'm going to give it a new image that it hasn't seen before. It's not available in this images that was trained by, just a whole new image of the same painter or the same artist, and see how it does when detecting the image. So over here, this is what was trained with, and the other folder I have here is new images that it hasn't seen before. I have a test image for Picasso, test image for Pollock, and test image for Rembrandt, and some test images of other artists as well, and see how it does, just to test it out. Okay? Now let's try and upload this first image and do a quick test over here. Let's try out this flowers image. That's not, it belongs to an unknown artist. We don't know who painted this. I'm just gonna upload it. Now let's see how it does. So the result over here is that it detected this as 99.9% painting. So it's sure that this is a painting, but it's not sure whose artist it is. So you see all of the probabilities of the other artists are very, very low. So this is not a good result. So meaning that it's not able to understand whose painter it is. And this is what we want, because this doesn't belong to any artist that I gave it earlier. Now let's try and upload an image for Picasso, for example, which I trained it to detect Picasso. This is a new image that it hasn't seen before. And you see as the result over here, it's 99% sure that this is a painting and 99.8% sure that this is a Picasso painting. So it understood the common features between Picasso paintings and detected that this is a Picasso painting. And it got very, very low probabilities for the other paintings, which is very, very perfect because it doesn't belong to any other artist other than Picasso. Now let's try out another artist for Pollock, for example, over here. And now testing, and detected with 99.9% for Pollock as well, which is very good. Now let's try out for another artist, which I didn't train it to detect, which is Van Gogh. So let's see if it did detect. So it has very, very poor probabilities for the other artists, meaning that it's only detected this as a painting, but it doesn't know who is this artist because it hasn't seen the artist before. So right now I have a very, very good model with very, very good results. Now let's see how can we use it inside of your own application. Okay, so this is my resource over here, and this has been trained with what I wanted it to train. Now let's try and connect to this endpoint So the way that you use this resource basically is I click on publish over here and just publish my document. And after publishing, I just get this result. I get this URL, which is my URL or my endpoint. So this is where my model was deployed on. It was deployed on this website or this server. And I have, in order to connect to it, I need to connect to it through the prediction key. This is my key. And the content type has to be added like this. Okay, so this is the option for connecting. So the way that I'm going to use this is I'm going to take this URL. This is my API. And then I'm going to add it inside of my application. So this is basically a C# application, just a normal C# application. And I'm just going to add in my details for creating an HTTP request. So if you've worked with C# before, this is where you create an HTTP request and you add in the headers, which is the key. So over here, this is my key, my unique key that I have to connect to my resource. And over here, this is the URL for my server. Okay, so let's add in the key. This. And I'll add in my URL. So these are the two options. So the first option, if you want to give it a URL, a URL for the image, if it's uploaded somewhere, and you just want to give it the URL, or if you want to upload the image itself. So for my own application, I'm going to upload the image because it's through C#. So over here under the URL, I just pasted the URL over here for the API. And now my application is ready with my information. So the two main things in the API is the API URL or the endpoint and the key to connect to this endpoint. And over here, these are just some additions to the request, just like the headers, what's the type of the header, and it's going to send the request. Now let me run the application. So if you have a website, if you have a mobile application, if you have any application that you want to integrate this into, this is how you integrate it. You add in the HTTP request, you add in the details, and then you send the image. So now I want to send out this image, for example, API. So I'll just take the path for the image and then type in the image name. Send it. And I'll get the result like this. So this is my result. The first prediction is 0.99% that is a painting and 0.97% that this is Picasso, and the rest with bad predictions of 0.008, 0.007. So I'll just take a threshold of 0.98 and then take my Picasso prediction over here and take this as a Picasso painting inside of my application. So that's it. That's basically how you use Custom Vision API in order to detect what you want inside of your own application. So if this is your website, if this is your mobile application, you just add in these two information and then send out the HTTP request and get the result in JSON like this, and gather what you want from the JSON result and then display it onto your own website. And that's basically how it's done over here as well in this demo website that I showed you earlier. Okay. Let's have a look at our resources as well. How did it do? So these are my metrics. And let's have a look at the calls. So these are the metrics for the calls available. And this is how many calls that were done. So approximately 50 calls or 50 requests were sent to Cognitive Services API after training the model and then requesting the model. You can also train this to detect whatever you want. So if I wanted to detect a fork inside of an image, if I want to detect a car, you can train it to detect whatever you want just by labeling the images as you upload them and have as many images as possible to send them out to the API request. Now let's try and see the result for OCR as well. So OCR is the optical recognition option that detects images and text inside of, text inside of images. So let's try out this API and let's try and send it an image of text. Let's take this image. And put it into my body to send it for the request. I'll get the key. And this is the result I got. Let's try out another one. For this one, for example. And I'll choose the language to be English. And choose another image as well. Let's try out this one. And apply it over here. And these are the results. These are the way you get the JSON results. So this is the image that we're sending out. So it has just some text inside of the image, and it was able to detect that this is an English language, and this is the orientation of the text. And this is the first word, which is one, and this is the bounding box, and this is the location of this first word. This is the location of the second word, the third word, and the fourth word. And it just combined it into bounding boxes, so just boxes that enclose on the rest of these images or the text. So this is the first word, and this is the second word. This is the first box, this is the second box, and this is the third box that combines them both together. So this is basically how you can try out OCR as well. If you have any documents with text inside of it, you can try them out. So I think that's basically it. If you want to try this out, if you want to give it a go, then you can definitely start with the image analysis. You can either start with custom vision or computer vision, or if you have something with text inside of it, then you try OCR. Just create a resource on your Azure resource subscription and send the request with the images or whatever you want to send, and then get the result in JSON like this and integrate it into your own application. Now, for the next session of our series, we're going to see how can we deeply invest into OCR and something called Azure Cognitive Search. So we're just going to create a search engine with our own documents, combining images and text all together. And we will be able to search for anything that we want inside of these documents with either text or images or text inside of images as well. So this is going to be our next session, and it's going to be hands-on as well. And thank you so much for attending today. I hope it was beneficial for you. I hope it was had enough information and informative. Feel free to try it out with your own subscription and try it out with the tutorials that we sent out on the event description as well. Now I'll be ready to look at the Q&A that you sent. If you have any questions or answers, we have 10 minutes to answer your questions.
That's great. Thank you so much for today's session and for taking the time to share your experience with our community. And it's great that you highlighted the upcoming session. So we have one more in this three-part series, and you definitely don't want to miss it. I dropped the link in the Q&A tab as an announcement, so you can register there and attend it. There are also a couple of modules that Dalia recommended for you to continue the journey on Microsoft Learn and continue this journey and explore more. So don't miss the next session. This is one. The second part, you don't want to miss what's happening on Microsoft Learn. And we have a question on the source code and resources, and if there is any developer guide for the vision services in Azure. Dalia, if you can share some links with our community.
Sure. So in regards to the demo that I just did, it's available that actually Hassan you just sent. So in the last message over here, that's for computer vision. It's available on Microsoft Learn, and it has all of the documents available and all of the detailed steps of what I just did. As well, on GitHub, you will find a lot of repositories available for you to, with quick starts, for you to just try them out. So I'll just send out the link for the documentation. And you can find all of the GitHub repositories with open source code that you can just connect to and try out. With developer guides as well. So for C#, for different application options for developing, you will find all the options available in the tutorial.
All right, great. We got some time for more questions. If you have any, please drop them in the Q&A. And I want to remind everyone that we are doing the survey to understand more the topics that you would love to see at the reactor. So spend a minute answering these questions and use the event code of today's session. It's 12716 on that form for us to get your feedback. So yeah. Exciting times. And also, quick reminder, we have this session recorded. You also want to make sure that you're subscribed to the Reactor YouTube channel. So the last session, I posted the YouTube link in the Q&A as well as an announcement. You can catch it there. And for today's session, after we end the stream now, it will be available to play back on the same link for the next, let's say, 18 hours. And by that time, the video will be on the YouTube channel. If you want to review it again, you want to share it with your network, that will be great. Tag us on socials and tag Dalia as well. Would love to see your interactions. And as always, the Reactor programming is free, open to all. All you need to be doing is to actually join us on Meetup and find the session that you love, make the time and join us online. We are streaming live and you can interact with us with all your questions. Right, I think that's it for today. Thank you, Dalia, again for joining us and looking forward to having you next week. Until then, stay safe, everyone, and have a great rest of the day.
Thank you so much, Hassan. Thanks, everyone, for joining. See you next time.
Goodbye.